Absolute value. Absolute value is denoted by these two bars you see here. No other reason they use these bars other than probably ran out of symbols, but they will help us in just seeing that absolute value refers to distance. You can think of those two bars as like a road. Picture yourself standing at 0 at the number line, and I ask you to go 4 spaces. Which way would you go? Well, as far as direction, you can go 4 spaces to the right towards the positive numbers, and you can go 4 spaces to the left as far as negative numbers. So absolute value deals with you standing at a point on the number line, and you're going a distance right and left from that point. All right, since we won't be required to solve absolute value with the equal sign here, I'm going to jump right into inequalities. Now our goal here is to solve for x, so we need to figure out how do I take x out of this absolute value. As you saw in the video, absolute value is distance where I can go both left on the number line and right on the number line. And on the number line, there's a positive direction towards positive infinity, and then there's a negative direction towards negative infinity. So again, absolute value is distance. I can go left and right. So I'm going to write what's inside here twice. And I can go towards the positive side and the negative side. Now, did anything change? 2x plus 3, 5? No. So my inequality sign is not going to change. However, here, notice that the sign got flipped, positive to negative. And what happens if you flip across the negative inequality? You have to flip the sign. So this less than symbol becomes a greater than symbol. So note here how this works out. I have an absolute value inequality. I'm going to rewrite it exactly how I see it minus the absolute value signs. Here, I'm going to flip this sign, and if I flip this sign, I also have to flip the inequality, which happens here. So make note of this change here. Stays the same, flip the inequality, flip the sign. And now you're just down to your regular linear solving inequalities. So I need to solve for x. So I need to subtract 3 on both sides. 2x is less than 2. Solve for x, divide by 2 on both sides. X is less than 1. There's left. Here, subtract 3 on both sides. 2x is greater than negative 5 minus 3 is negative 8. Divide by 2 on both sides. X is greater than negative 4. So now what I want to do is to graph this to see how it looks. So I'm going from, let's see, negative 4 here to 1. X is less than 1. Notice I don't have an equal sign, so I'm using parentheses. It is less than. X is greater than negative 4. No equal sign, so parentheses. Greater than negative 4. And I see where do they pair up? Where do they come together and intersect? Well, in the middle. So between negative 4 and 1. And if I were to write this in interval notation, I see it's open parentheses, negative 4, comma, 1, close parentheses. There's my solution in interval notation, solving this inequality. So note it, it's a linear inequality, but it's hidden that it's 2 linears and 1. Because absolute value just deals with distance, going both left and right on the number line. So for this next problem, note that the previous problem had the absolute value by itself. There was no 5 being multiplied, nothing being multiplied or added to the absolute value. It is by itself on one side of the inequality. That's what we need to do first before we can separate this out. So I have to get rid of all this extra stuff here and get absolute value by itself. So let me first look at this 1 being subtracted. Opposite of subtracting 1 is to add 1 to both sides. It's 5 times my absolute value is greater than 10. And now I can work with this 5 here. Opposite of multiplying by 5 is dividing by 5 on both sides. I have the absolute value of 2x minus 3 is greater than 10 over 5 is 2. So now that I have the absolute value by itself on one side of the inequality, I can separate it out. I'm going both left and right on the number line. So 2x minus 3, 2x minus 3. I'm going both in the positive direction and the negative direction here. And since nothing changed, I'm going to keep the sign the same. Since I changed the sign, I have to change or flip the inequality. So note, I didn't flip the signs on the left. the signs that were within my absolute value. No, I only flipped the sign that was on the right, that number there. That's the only thing you're going to flip. You're not going to flip any of these values here. Okay, now that I have my two linear equations here, I'll go ahead and solve them to finish this question off. Let me add 3 to both sides. 2x is greater than 5. Divide by 2. I see that x is greater than 5 halves. And on this side, again, let me add 3 to both sides. 2x is less than 1. Divide by 2. X is less than 1 half. So let's see what these values look like on a number line. I have 1 half and 5 halves. This one says x is greater than 5 halves. I don't see an equal sign, so I'm going to use parentheses. Greater than, I see the arrow pointing this way. X is less than 1 half. Again, I'm going to use parentheses. Less than, going towards my negative infinity. And here's my graph. And if I were to write this in interval notation, I see them going from negative infinity to 1 half. And at 1 half, I have a parentheses. The union of open parentheses, 5 halves, going all the way to infinity. So notice how my answer in interval notation is all separated. Likewise is my graph, separated. 9 times out of 10, that's what's going to happen when you have a problem in absolute value that is greater than. The previous problem, it was less than problems come together and form a line, create one type of interval notation. Greater than is separated, so that should give you kind of a hint of what to look for. Less than, it should come together and connect.